Hello and welcome. From today we are going to start our new lecture series about the basics of quantum computing. In this lecture series we will discuss the basic of quantum computing, how it works, how it differs from the classical computer, why we actually need quantum computing. We will discuss the basic concepts of quantum physics on which a quantum computer works, how its hardware is different from the classical computer. All those things we will discuss. But before actually starting the course, you should first know why you need to study this topic, why you need to know about this technology. Well, quantum computing, it's not just an academic topic to study, but it is the future of computation. By using some basic principles of quantum physics like superposition and entanglement, it can solve problems at a very high speed, which is unattainable by today's most powerful supercomputer. Many industries have already started adopting this technology for their innovation and better performance. If you ask me what a quantum computer can do, I would say it has some magical capabilities in it. You guys must have heard about the famous quantum coin toss experiment. In this experiment, a coin was tossed, and before knowing the result, whether it's a head or a tail, you are given a chance if you want to flip the coin or not flip the coin. Then computer was given a chance if it want to flip the coin or not flip the coin. Then again it's your turn. You will decide whether you want to flip the coin and not flip the coin. The process is repeated 4 or 5 times, and after that the result was revealed. Suppose you have chosen head, and if it's a head you will win, and if it is a tail, computer will win. If you play the game with a classical computer, you know there are 50% chances of your winning and 50% chances of winning the computer. But if you play the game multiple times with a quantum computer, the quantum computer wins every single time. Almost 100% winning chance of quantum computer. How it is done, we will discuss in the subsequent lectures. There is another term which we call quantum supremacy. What it is? Well, a complex problem is solved by quantum computer at a very high speed, which is unattainable by the supercomputer. Recently in 2019, Google has announced that by using their quantum computer Sycamore, they have solved a quantum computation in just 200 seconds. And if you give the same problem to a classical computer, it will take 10,000 years to solve. Again, show how much potential a quantum computer has in it. Then recently, China has announced that they have done a telecommunication at a 1200 kilometer distance instantaneously. Means they have sent a data instantaneously to a distance of 1200 kilometer. In subsequent lectures, we will see how these things are done by a quantum computer. If we talk about implications of quantum computing, it is a multidisciplinary field. It has actually revolutionized the way how we approach a problem, how we can solve it, and how we can innovate using it. Like a material scientist, by using quantum simulation, can predict property of a material very well before it is actually synthesized. It will accelerate the production of new material, which will be critical for drug industries, for aerospace industry, for electronic industries, for battery sector, etc. Also, sectors like banking and finance, where data security and speed are very crucial, quantum computing can provide significant advancement. Like in cryptography, it can increase the data security by using quantum key distribution, a process where a data can be transmitted with theoretically unbreakable encryption, which will set a new standard for data security, right? A number of industries have already started using quantum computing for the better performance, for their better innovation. Here are a few examples of them. So, quantum computing is definitely the future technology, and if you want to know the basic principle of quantum computation. Stay tuned for subsequent lectures. Thank you.